Hello everyone and welcome to this tutorial on amplitude modulation. My name is Mohammed Safa, and in this tutorial I want to show you what we mean by amplitude modulation and how to implement an amplitude modulation system practically using MATLAB. So let's get started. The tutorial is structured as follows. First, introduction, then AM modulation and AM demodulation. Then we'll see how to implement the system practically using MATLAB, then a code walkthrough, and finally the conclusion. Introduction. What is modulation? So basically, every communication system works at a specific carrier frequency. This could be in kilohertz, in megahertz, or even in gigahertz, like Wi-Fi and Bluetooth systems. And the idea of modulation is basically how we can put information or input signal on top of this carrier signal, like this example carrier signal here. And we have basically three main methods. We can change the frequency of our carrier signal in accordance with the input message, and this is known as FM or frequency modulation. Or we can change the phase of our carrier signal in accordance with the input message. This is called PM or phase modulation. Or finally, and the most simple method, is that we can change the amplitude of our carrier signal in accordance with the input message. This is known as AM or amplitude modulation. This is basically the subject of this tutorial. So what is amplitude modulation? Amplitude modulation is simply that we have a carrier signal and we can change the amplitude of this carrier signal in accordance with the input signal. Like for example, if we have this carrier signal with amplitude 1 and this input signal, performing modulation or performing AM modulation, we can get the following AM modulated signal. Here we can notice that this is our carrier and the amplitude of our carrier is changing in accordance with the input signal, and simply this is AM modulation, and this red curve here is our input signal, and we can notice how the amplitude of the carrier signal is changing in accordance with it. So in general, this is the equation of, or the general equation of AM modulated signal. Here we can notice the carrier signal here, and here the red curve or our input message, we can see it here. So simply we are changing the amplitude of our carrier signal in accordance with the input message. And we have important parameters here. For example, the carrier frequency, FC, the modulation index, M, and of course our input signal, which is normalized to a maximum absolute value of 1. So let's see what is the modulation index, or what's the modulation index do. So modulation index, which is basically ranges from 0 to 1, has the following effect, as we can see here in these two figures. So for example, if the modulation index is 1, which is the maximum value, we can see that the amplitude of our carrier signal varies all the way to 0 and then goes up again. On the other hand, if the modulation index is half, we can see that the carrier signal amplitude goes half its value, which is 1. So goes to half its value, which is half, and then goes up again. This is basically the effect of the modulation index. AM demodulation can be done simply by extracting the amplitude of our carrier signal, which is called envelope detection. And traditionally, this operation can be done using a circuit, a dedicated circuit that achieves this job. However, in this tutorial, we'll implement the demodulation using digital signal processing, which is how most, if not all, current communication systems work. So these figures here show how we will implement the AM modulation and demodulation. So we will use an audio input and we'll use 3 users. We will have some pre-processing. Here we can have, for example, low pass filtering and addition, multiplication, and so on. Then Each user will be multiplied by its corresponding carrier signal, which has a unique frequency or carrier frequency. Then the signal will add up and transmitted, or in our case, will be saved as an audio file, a wave file. At the receiver, we will record the audio signal using MATLAB. Then we will multiply by complex exponential with the corresponding carrier frequency. Then we will do some processing, which is envelope detection, low pass filtering, and so on. And we'll see the details in MATLAB. So why we multiply by complex exponential at the receiver? So for example, we have the following received signal, which has the information on the amplitude that we want to extract, and this is the carrier signal, and some unknown phase that we don't know. We multiply it by the complex exponential with the required frequency, and if we do the math, we get the following two terms. We have the baseband complex term, which has the information as the amplitude and some phase corresponding to the phase, the unknown phase. And we have other term, which is double the carrier frequency term. This term can go away using low pass filter. And this term, we can take the absolute value and we can extract this information from the complex baseband signal. And this is basically and simply the envelope detection. So let's see the details in MATLAB. So now we will see the MATLAB code that is used to implement the AM system. The code consists of several parts, and we will start from the first part, which is the parameters section. This part consists of the main parameters that are used in the design. So first we have the sampling frequency. This parameter depends on the audio card of your system. So check the audio settings in your control panel and set it as the sampling frequency of your audio card. Then we have three carrier frequencies. These are the carrier frequencies that are used by the users. So each user has a unique carrier frequency. Then we have the input message duration. So we will record an input message of 3 seconds for each user. Then we have the cutoff frequency of the low pass filter. So we will have a band limited signal of 1.5 kilohertz. Then finally we have the modulation index. So you can experiment with these parameters, but for the sampling frequency you have to set it as the sampling frequency of your audio card. Then we will record the input messages of our 3 users. So let's start by running this section using Control and Enter. Then we will run this section. This section just record an input message for each user and perform low pass filtering, and then normalize the message to a maximum absolute value of 1. So let's run this section also by Control and Enter, and we will record 3 input messages for our users. Input signal 1, input signal 2, input signal 3. So we recorded 3 messages for each user. These are the spectrums of the input messages. So we notice that it is band limited, and each user has its unique input message. Then we will perform the AM modulation. This section generate first the carrier frequency, then perform the modulation using this modulation equation, then add the messages of each user, and we will see the spectrum of the AM modulated signal. And finally we can save the signal as an audio file, a wave file, if we want to play it back from our phone. And we have other option that we can play it and record it from our computer, from the same system. So now we will not use the audio file, we will record it and play it from our computer directly, but you have this option to experiment with if you want. So let's run this section also. Notice here, this is the AM modulated spectrum. As you remember, we have three main carrier frequencies, 13, 9, and 5. We see them here. So at each carrier frequency, we have the signal of the user. So for example, this is the signal of user 1, this is the signal of user 2, and this is the signal of user 3. So this is the AM modulated signal, and we will transmit or record this signal to do the demodulation. So if you want to play the signal from your phone, you can comment this line and play the signal from your phone and run this section. This is what we will do here. We will play the signal and record it from the same system, from the same computer. And also you can comment all these lines, and if you want for simulation to have the signal directly for the receiver without recording it and without any distortion. So now we will play, this line will play the transmitted signal, the AM modulated signal, and record it at the same time from the same system. So let's run this section. So this is the received signal. Notice that it has some noise because there is some noise in the environment, and there is some harmonic distortion because the speaker is not perfect, the mic is not perfect, but we can notice clearly the three users here. We have this at 5K, at 13, and at 9. So let's do the demodulation by running this section. So what's the modulation? The modulation, first we will generate the carrier frequencies, then we will multiply the received signal by each one by its corresponding convex exponential. So this is the received signal. For user 1, we'll multiply it by the complex exponential of user 1. Then we'll perform a low-pass filtering. Then we will take the absolute value, which is simply the envelope detection, and then we'll remove any DC in the signal. And we'll do the same thing for each user. And we will get the following spectrum, the following received signal spectrum. So let's listen to the received signals. So let's listen to the signal of user 1.
Input signal 1.
So notice that it has some distortion, it has some noise because of the environment. It's not perfect, so let's listen to the input signal. This is the input signal.
Input signal 1.
And notice the output signal.
Input signal 1.
We can also listen to the other users' signals. So this is user 2.
Input signal 2.
And this is also user 3.
Input signal 3.
So we can notice how the AM system is very susceptible to noise, and the noise affects the received signal very much because it's modulated on the amplitude. So any distortion, any variation in the amplitude will distort the received signal. So for example, we can play noise deliberately. So I searched in YouTube for white noise, and I will play it in my phone while I record the received signal. And let's see its effects on the demodulated received signal. So I will run this section and I will play a white noise on my phone, and we will see what we will get after the demodulation. So this is the received signal spectrum. Let's run the demodulation. Let's see the received signal. So this is user 3.
Input signal 3.
Notice the effect of the noise. So let's listen to signal 2.
Input signal 2.
Notice how the noise affects the received signal very much and distort it.
Input signal 1.
So this is, as we said, one of the limitations of AM modulation, and it has no immunity against noise. So let's move on to the conclusion. So in conclusion, first we saw what we mean by modulation and what are the methods that are used to modulate signal on top of the carrier signal. Then we saw the amplitude modulation, amplitude demodulation. We saw the modulation operation and what is the modulation main equation, and we saw the shape of the modulated signal. Then and during the MATLAB implementation, we saw the limitation of the amplitude modulation and how the system has no immunity against noise, because simply the information is modulated on top of the carrier signal amplitude, and any variation in the amplitude because of the noise will affect the received information. And finally, you can modify and experiment with the MATLAB code to further enhance your understanding of the system.